Okay, so we're looking at a formative quiz to give you an idea of what the sort of questions you're going to be asked to do. Okay, so in the first question, we're just going to convert some simple rates. So pause the tape, and when you're ready, come back live. Okay, so in the first one, normally rates would be meters per second, but you could have seconds per meter, but we'll stick with the traditional one. Let's get my colours right. So 400 in 60 seconds equals 400 divided by 60 in 1 second. And on your calculator, just get my calculator out. 400, turn the calculator on, 400 divided by 60, 400 clear, 400 divided by 60, so it's 6.67 meters per second. Okay, so that's the first one. Next one, okay, we could have litres per dollar or dollars per litre. So it depends which way you want to go. I'm going to go for dollars per litre, which means I've got to put the $3 first. So $3 for 2 litres equals 3 over $2 for 1 litre. So then that's your answer. So $1.5 per litre. Okay, so we just got to convert it to 1 at the back, and once you got 1 at the back, that's going to be the rate. Okay, so if we want to have litres per dollar, we'd have 2 litres for $3 equals 2/3 of a litre for $1, and so it'd be 2/3 litres per dollar. So that answer would also be right. Okay, come across when you're ready. Okay, so convert the following rates: meters per second to kilometres per hours, millilitres per second to litres per hours. So check your notes if you need to, but when you're ready, come back. Okay, so we've got to get into hours. So that's going to be 1 second. So we're going to go 3 times 60 meters per minute. So now we've multiplied by 60, and then 3 times 60 times 60 meters. Now I'm in hours. So I've gone by 60 twice, and then I want kilometers. So I've got 3 times 60 divided by 1,000 kilometers per hour, and let's see what that answer equals. So 3600 times 3, and so that equals 10.8 kilometers per hour. So i.e., if you're running at 3 meters per second, you're going 10.8 kilometers per hour. Okay, let's see the next one. Okay, so we've got seconds, and we've got to go to hours again. So let's save some time. So 60 seconds times 60 minutes, and now I'm in hours. And then millilitres to litres is divided by 1,000 again. Divided by 1,000. And now I'm in litres per hour, and that answer, 360 times 15. Okay, so that's 54 litres per hour. So if your tap is dripping at 15 millilitres per second, it's 54 litres per hour. Okay, come across when you're ready. Okay, if I run 6 meters per second, how far do I run in 2.5 minutes? How long do I run in 10? How long do it take to run 10k? So I'm going to do this with a direct variation, because any time you have a rate, you can do as a direct variation. Okay, so let's say distance equals, so 6 is the constant, times t. So distance is in meters, time is in seconds. Okay, so the first question is 2.5 minutes. So 2.5 minutes, but each minute is 60 seconds. So that's going to be the first one. My calculator is on my table. So 6 times 2.5 times 60. So I'll go 900 meters. That's part A. B. Okay, so so distance equals 6 times time is still the same formula. Now distance is in meters, so I've got to convert that. So I've got 10,000 equals 6 times t. So t equals 10,000 over 6 equals 1666.67 seconds. And if you wanted to, you can divide that by 60. If you wanted to, you don't have to. So that's 27.77 minutes, and that's close enough. Okay, which is that's a pretty good 10k time, 27.77 minutes. Okay, coming across when you're ready. Okay, so now I've got some questions that are direct variation, but we have to find the formula. Okay, so when you have, just remember, when you have direct variation, you got y equals kx. Okay, so that's the direct variation formula. So have a go at that question, and when you're ready, come back live. Okay, so we haven't found the value of k, so we've got the value, we've got 10 equals k times 4, so k equals 10 over 4, which is 2.5, so that's the value of constant. So form an equation, so the equation is y equals 2.5 times x, so that's the equation. Okay, then use the equation to find x when x equals 5, so part 1, y equals 2.5 times 5 is 7.5, and in part 2, okay, 18 equals, not 6, sorry, 2.5, 18 equals 2.5 times x, so x equals 18 over 2.5, and on your calculator, that equals 7.2. Okay, come across when you're ready. Okay, now we've got an indirect one, and again, just to remind you, y equals k over x is the formula. So you need to find the value of k and then answer the questions when you're ready. Okay, so you're back, maybe. So we've got 20 equals k over 4. So k equals 20 times 4, so k equals 80. So form the equation. So y equals 80 on x is the equation. So part 1, y equals 80 over 6. On your calculator. So it's 13 1/3 or 13.3 repeater. Okay, in part 2, when you have to find x, what we're going to do is switch the positions. So x equals 80 over y, so you can do that. And 80 over 8, so the answer is just 10. Okay, come across when you're ready. Okay, so we've got data collected from an experiment on the oval like we've been doing before. There's the distances, construct a travel graph, and then use, like we've been doing, the fastest, the slowest, and the average. So have a go, and when you're ready, come back. Okay, let's have a look. So the biggest distance is 30 metres, so 10, 20, 30. That's the biggest distance, and we've got to go to 20 seconds. So 4, 8, 12, 16, 20. And distance in metres, so put the scale on, otherwise you won't get the full marks. So it starts at 0, at 10 metres it's 4, at 20 metres it's 6, at 30 metres it's 10, at 30 metres it's 12, at 10 metres it's at 18, and back home. Okay, so we've got that, and then that, and then that, and then that, and then down, and down. Okay, so that's your travel graph. Okay, so let's just do the speeds as we go along. So between there and there is 10 over 4, which is 2.5. Between there and there is 10 over 2, which is 5. Between there and there is 10 over 4, which is back to 2.5.
there to there is 0, there to there is 20 over 6, which is 3 1/3, and there to there is 10 over 2, which is 5. So the fastest speed, I've got a 5 there, and I have a 5 there, so the fastest speed is 5. The slowest speed is 0 meters per second, cross out that. Now the average speed is how far have they gone. Now in the trip, they've just kept going out the whole way and then back, so that means they've gone 30 out and they've gone 30 back because they didn't do any sideways trip. So the total distance is 60 meters and the total time is 20 seconds, so the average is 3 meters per second. Now just remember, if there's any trips back, you've just got to add up those distances, but this was going out and then coming back without any side trips. So that's it. Okay, come across when you're ready. Okay, so I've got some containers I got off the internet, describe how the rate of change, how the water going in changes. So what I'll do is I'll just put some dots on the curve. So it's a dot there, dots, dots, dot to there. Oh no, it's gonna, maybe the dot should be actually there. And then back out. Here, that, probably about there. Okay, so have a go. If we're talking about increasing rates and constant rates and things like that. So when you're ready, come back live. Okay, so this section here is going out. So it's increasing at a decreasing rate. And then this section is going to be also increasing at a decreasing rate, but it's going to be slower. And then this section here, or all this section here is increasing at an increasing rate because it's getting smaller, and then up here it's going back out again, so it's increasing at a decreasing rate. So there's no constants. Here, this glass here looks like increasing constant because it's a constant shape, and then it's going out, so it's increasing at a decreasing rate, and then I think it's going in slightly. You could argue that it was going straight up, but it's here, it's increasing at an increasing rate, because I reckon it's going in slightly. But if you had increasing constant, I wouldn't be too cross. Okay, come across when you're ready. Okay, so now we have to design a container that matches the following graph. Okay, so we've got, just remember we've got increasing, decreasing, and then constant, and then constant. So see if you can design a vase or a glass or whatever that matches that. Come back when you're ready. Okay, so the first section is increasing, so let's design it. So we have to have a base. Okay, so it's sitting on a base. It's slowing down, so that means it has to be going out. Okay, somehow going out. And then it's constant. Okay, so this at this section here, I'll just change colours, but it's going to be constant, which means it has to be a constant shape. Now this section here is also constant, so that means somehow at this section here it's going to stop, and then we've got another constant shape on top of it. Okay, so somehow this glass somehow has some sort of lid. Okay, and then we've got another constant, but it has to be a quicker constant, so something like that. Okay, so that's it. So hopefully that gives you an idea about what most of the tests will be, or most of the tasks will be on. Enjoy.